Hi viewers, today we will be discussing some basic terms in geometrical optics, and these videos is for undergraduate optics program, and videos will be very short and the contents will be uploaded in weekly basis, right? And today we'll be discussing geometrical optics. Okay. The geometrical optics fundamentals. As we know, we use lens and geometrical optics, and the center axis of the lens, that is the horizontal axis, is called as the principal axis, and the vertical axis of the lens, that is this region, is called as a optical axis. The point at which the principal axis and optical axis meets the lens is called as an optical center. Right, these are the terms which we have to remember, right, while studying lens systems or while studying the lens formula, right? As I said, these are the terms as we discussed. There's a principal axis and there's a parallel rays coming into this lens and passes through this lens, and it get converged at the point, and that point is called as a focus. And the distance between the optical center and the focus is called as the focal length, and there's a relation between focal length and radius of curvature of the lens. And as in lens system, we have a convention that the left hand side, where that the light rays coming in is considered as a negative, and the distance between the lens and where the light converges is called as, is given by the symbol plus. We use positive symbol here, right? These are the things, these are the conventions which we use during or solving the lens optical system. Then we will be discussing aberrations. The aberration, a property of an optical system such as lens, that causes light to spread out over some region of space rather than focus, or rather than focused at a point. Instead of focusing at a point, the light or image formed by the lens is blurred or it's not a clear, right? That's called as aberration. We are not able to get the sharp image of that object, right? That's called as a aberration. And there are different types of aberrations are there, and particular we will classify. One is the monochromatic aberration, and this is the lowest order aberration. This will happen very normally in lens systems or optical systems. And next we will be having the chromatic aberration, and this is due to the dispersion of light in the corners of the lenses, right? And we will discuss one by one in detail. As we know very well, monochromatic, we will be using light of single wavelength, and in chromatic we will be having the colors are produced due to the white light rays, right? Monochromatic will be having single color, chromatic will be having more than one color, right? Next we will be discussing this monochromatic aberration. This monochromatic aberration includes spherical aberration, coma, astigmatism, and distortion, right? These are the four aberrations which is given under monochromatic aberration of lowest order. And this next we'll be discussing the spherical aberration, and light rays focusing a different point after passing through the spherical surfaces, and lens and curved mirrors are often made with surfaces that are spherical. As you know very well, the lenses are made from the spherical surfaces or spherical glasses, right? And as is there, if there is any failure in cutting of lenses or that glasses, it will lead to this spherical aberration. See here, if we have a normal and well designed lens here, we will be having the image at a point, that is focused at a single point, right? Focused at a single point. But in the case of improper or designed with error, the lens produces the images at different points, right? And this leads to the spherical aberration, right? And next we will be having chromatic aberration, and this is due to dispersion, and this is of course due to the dispersion of light. Lens edges unable to bring all wavelengths of the color to same focal point. They are focused in a focal plane which is with different focal points, right? For example, this is the focal plane, the plane at which this is the focal plane, right? And here you can see that different wavelengths are focused at different points, right? Focused at different points in optical axis, and this is called as a chromatic aberration. Because why it is happening? Because the edges of the lenses acts as a prism, and it disperses the white light, and as a result of that prism, what happens, that white light is dispersed, and different colors of lights are given here, are formed here, right? This is mainly due to the dispersion of the lenses, dispersion of the light, which is achieved by the uh, dispersion at the edges, because that edges acts as a prism. The prism, as you know, that the white light is it consists of Vibgyor colors, so it separates white light into different colors, and each color will form a image in this optical axis, and unable to, and this makes that unable to bring all wavelengths of color to same focal point. Instead of having image at one focal point, we have different focal, more than one focal points here, right?